Hello students. Here we go with an illustrative example for simplex method. To tell about the simplex method is a basic building block for all the other methods to solve the linear programming problem. We shall consider an LPP, linear programming problem. The objective function of the LPP is maximize z is equal to 6x1 plus 8x2 subject to five x1 plus 10x2 less than or equal to 60, 4x1 plus 4x2 less than or equal to 40, x1 and x2 greater than or equal to 0. In this LPP, this maximize z is equal to 6x1 plus 8x2 is called the objective function. And these two are the constraints. And this is the non-negativity restriction. Yes. Now, writing this in the canonical form of this is given as z is equal to 6x1 plus 8x2 plus 0s1 plus 0s2 subject to the constraints 5x1 plus 10x2 plus s1 plus 0s2 is equal to 60, 4x1 plus 4x2 plus 0s1 plus s2 is equal to 40. And here x1 non-negativity restrictions will include all the variables x1, x2, s1, s2 greater than or equal to 0. In the given question we have less than or equal to, which means that the left hand side is somewhat weaker than the right hand side. In order to make this inequality into equal, we add the basic variable. We add a basic variable to the left hand side so that the less than or equal to will be converted into equal to. This is said to be canonical form. When the standard form which has less than or equal to type and we add the basic variable such that in one constraint the coefficient of a basic variable is 1, in all the other constraints its coefficient is 0. In the first constraint the coefficient of s1 is 1 and in the next constraint the coefficient of s1 is 0. And in the second constraint the coefficient of s2 is 1 and in all the other constraints the coefficient is 0. Coefficient of s2 is 0. Therefore this can be called as canonical form. Okay, now we shall move on to the initial simplex table. In the initial simplex table, let us start with the basic variable. S1 and S2 are the basic variable. In the less than or equal to type, the basic variable is also called as the slack variable. When the inequality is less than or equal to type in the constraint, S1 and S2 are slack variable. Yes. Now starting the initial table, initial simplex table. First, basic variable, and we have coefficient of basic variable. Next, coefficient of objective function. We're going to write all the variables here. We have x1, x2, s1, S2. And then we have solution and then ratio. First, we are going to start with the coefficient of objective function. Coefficient of x1, this is the objective function, right? This is the objective function. Coefficient of x1 in the objective function is 6. Coefficient of x2 in the objective function is 8. Coefficient of s1 is 0 and coefficient of s2 is 0. And basic variable, we have s1 and s2 or the basic variable. Coefficient of s1 and s2 in the objective function is 0. Now we write the coefficient of the first constraints. First constraint 5, 10, 1, 0. So 5, 10, 1, 0. And in the right hand side we have 60. Next, in the second constraint we have 4, 4, 0, 1, 40. Okay. So after entering all the coefficients, we come to Zj. In the initial simplex table, Zj, the elements of Zj will be 0. All the elements of Zj will be 0. How come? Means we are multiplying the coefficient of the basic variable, the 0 and 0, to the technological coefficient. So 0 into 5 plus 0 into 4, that is equal to 0. In the first initial simplex table, the elements of Zj will be 0. Next comes Cj minus Zj. We have Cj, this is our Cj and Zj. Yes, Cj minus Zj. 6 minus 0, which is 6. 8 minus 0, 8. 0 minus 0, 0. And 0 minus 0, 0. Now, in Cj minus Zj, we have 6, 8, 0 and 0. Here, we are selecting the maximum element, that is the largest element of this row. The largest element is, among the 4 elements, is 8, right? 8 is the largest element. So we are selecting this 8 and we are selecting the column that contains 8. So this column, we are selecting this column. We call this column as key column. This column is called key column. And this variable is called entering variable. Okay. Next, we are going to find out the ratio of the solution to the corresponding key column element. So solution is 60 and the corresponding key column element is 10. So 60 by 10, which is equal to 6. Next, solution 40 and the corresponding key column element is 4. So 40 by 4, which is equal to 10. Now among 6 and 10, we are selecting the minimum element, that is 6. Okay, so the row that contains the 6, this row is said to be key row. Key row. And this element S1 will be leaving variable. So the first row, this is the key row and this one is the leaving variable. Now the element that is in the intersection of key column as well as key row, the intersecting element, this 10, we call 10 as pivot element or key element. Pivot element or key element. Now, in our next iteration, we will make this pivot element 1 and the corresponding column element, that is the 4, the corresponding column element of the pivot element 4 into 0. So our next time, the next iteration will involve steps that will make this pivot element 10 to 1 and the corresponding column element 4 to 0. Okay, yes. So here comes this first iteration. After the initial simplex table, we start on with the first iteration table. Table will be similar. We have no changes in the setting the table. Basic variable and coefficient of that, and coefficient of objective function, variable x1, x2, s1, s2, solution, and then ratio. The coefficient of the objective function will remain the same in all the iterations. 6, 8, 0 and 0. That will remain the same. 6, 8, 0, 0. And our first step in the first iteration will be this S1, as I've already told you, this is the leaving variable. So S1 will leave and the entering variable x2 will be replaced here. So we'll replace this S1 with this x2. S1 will be replaced by x2 and S2 will remain the same. The coefficient of x2 is 8 in the objective function and the coefficient of x2 is 8 and S2 is 0. Now, our first aim is to make the pivot element 1. That is, we have to make this 10 to 1. That is, we'll divide this first row throughout by 10. Okay, 5 by 10, 10 by 10, 1 by 10, 0 by 10, 60 by 10. So, 5 by 10, 10 by 10, 1 by 10, 0 by 10, 60 by 10. Right? This is the first step. We made this pivot element 10 into 1. For that, we are dividing all the elements of the first row by 10. 5 by 10, 10 by 10, 1 by 10, 0 by 10 and 60 by 10. 5 by 10 can be written as 1 by 2. 5 by 10 is nothing but it can be written as 1 by 2. And 10 by 10, it is 1. 1 by 10. And next 0 by 10 is simply 0. 60 by 10 is 6. Yes. And after making the pivot element 1, we are going to make the corresponding column element, that is this 4 to 0. Okay. For that, we'll use the following formula. New value is equal to old value minus key column value into key row value divided by key value. Key value is nothing but the pivot value. So first we are going to find out the new value for the old values 4, 4, 0, 1 and 40. Okay. First we are going to find out the new value for this 4. Okay. So the old value is 4 minus key column value. The corresponding key column value for this 4 is 5. 5 into key row value. The corresponding key row value for 4 is this 4. 4 and the key value is 10, which is equal to 4 minus 20 by 10, that is equal to 4 minus 2, this is equal to 2. So here we are having 2. The new value for 4 is 2. And next we have once again 4. The second value, this is the first value. And the second value, old value is 4 minus key column value. Key column value is 10. And the key column value is 10 and the key row value is 4. Key column value is 10 and key row value is 4 divided by the key value 10. So this is equal to 4 minus 40 by 10. So this is equal to 4 minus 4. This is equal to 0. So the second value is 0. This is what we were intended to make, right? The pivot element to 1 and the corresponding column element to 0. In order to make this element 0, we are using this formula. Now the third element. Third element in the initial simplex table is 0, right? We have find out the new value for 4. Now we are going to find out the new value for 0. Old value is 0 minus the corresponding key column value. Corresponding key column value for 0 is 1 and the corresponding row value is 4. So 1 and 4. 1 into 4 divided by key value is 10. So this is equal to 0 minus 4 by 10. 4 by 10 can also be written as minus 2 by 5. So here we have minus 2 by 5. The last, in the technological coefficient, the last value is 1. We are going to find out the new value for the old value 1. The corresponding column value is 0 and the corresponding row value is 4. 0 and 4. So for the fourth value, old value is 1. Yes. Old value 1, corresponding column value 0, corresponding row value 4. 1, 0 and 4 divided by key value 10. So 1 minus 0 is 0. 0 into 4 is 0 by 10, which is also 0. So 1 minus 0, which is equal to 1. So the new value is 1. Similarly, we should also find out for the solution. We have 40. 40, the old value is 40 minus the corresponding column value 60, row value 4, right? So, should move on to the next page. So for the solution, old value 40 minus corresponding 60 into column value 60, row value 4 divided by the pivot value, key element. 40 minus 10 and 10 will get cancelled, right? Or else 240 divided by 10. That is equal to 40 minus 24, which is equal to 16. So the new value will be 16 here. And next we'll find out Zj. In order to finding out Zj, we will multiply the coefficient of basic variable here. We are going to multiply this 8 with the technological coefficient 1 by 2, 1, 1 by 10, 0 and 6. Since we have 0 here, even if we multiply and add, the value is not going to change. 0 into 2 is going to be 0 and 0 into 0, 0, 0 into minus 2 by 5, 0, 0 into 1, 0, 0 into 16, 0. So we need not consider the second row. It is enough that we multiply this 8 throughout. So 8 into 1 by 2. To be more clear, what I am going to do is first 8 into 1 by 2 plus 0 into 2, right? 8 into 1 by 2 plus 0. 8 into 1 by 2 plus 0 into 2. Okay, that is what I have written. Let me erase. Kindly keep it in mind. 8, 0. This is S2. 1 by 2 and 2. I suppose I'm correct. Let me check. So 8 into 1 by 2, we shall cancel this out. 4. 4 plus 0 into 2 is 0. So this is 4. So here we will have 4. Similarly, we do all the calculations. 8 into 1 is 8, plus 0 into 2, the plus 0. 8 into 1 by 10. So 8 by 10. Plus 0 into minus 2 by 5, which is not going to change. So 8 by 10. 8 into 0, once again 0. 8 into 6, 48. Lastly, we will have Cj minus Zj. Cj 6 minus 4, which is equal to 2. 8 minus 8, 0. 0 minus 8 by 10 can be written as 4 by 5, right? So 8 by 10 is 4 by 5. So 0 minus 4 by 5 is minus 4 by 5. 0 minus 0, 0. Yeah. Cj minus Zj can be called as solution deciding step, right? Because when all the elements of Cj minus Zj are either 0 or negative, it means that we have obtained the solution level. Till we get the positive values for maximization objective function, we have to proceed with the next iteration. Okay, right. We have 4 elements here, and among the 4 elements, 3 are either 0 or negative value. 0, minus 4 by 5 and 0. These are either 0 or negative value. Only one we have positive value, that is 2. So 2 is the maximum value here, and hence we are selecting the column that contains this 2. This is said to be key column, and this element is the entering variable. This is the entering variable, and now we are going to find out the ratio. 6 ratio to the solution and the key column elements. This 6 and 16 should be divided with 1 by 2 and 2. So 6 divided by 1 by 2. 6 divided by 1 by 2. Or this can be written as 6 into 2. 6 into 2, right? That is equal to 12. 6 divided by 1 by 2, or 6 into 2, that is equal to 12. Next, 16 divided by 2, that is equal to 8. Right? Here we are going to look for the minimum element. Among 12 and 8, 8 is the minimum element. Hence we are selecting this row. As we have seen in the initial simplex table, this is our key row, and this S2 will be leaving variable. And this 2 is the pivot or key value. Pivot element or key element. Now, in the second iteration, we are going to convert this pivot element to 1 and the corresponding column element 1 by 2 as 0. Right? Yes. Once again, we are setting the table. Basic variable. And Cbj coefficient of basic variable and Cj coefficient of objective function. All the variables x1, x2, s1, s2, ratio, solution and ratio. Now, since here S2 is the leaving variable and X1 is the entering variable, right? S2 is the leaving variable and X1 is the entering variable. We are going to replace this S2 with the X1. S2 should be replaced with X1. So X2, X1. The coefficients, we are going to write it the same, 6, 8, 0, 0. 6, 8, 0 and 0. The coefficient of x2 is 8 and the coefficient of x1 is 6. Now we are supposed to convert the pivot element to 0, right? Sorry, pivot element to 1 and the corresponding column elements to 0. We have pivot element in the second row. Yes, in the second row here. The technological coefficients row, we are second constraints, we have this 2, that is the pivot element. Therefore, we are going to divide this 2, 0, minus 2 by 5, 1 and 16. These 5 elements by 2, the key value. So 2 by 2, 0 by 2, minus 2 by 5 divided by 2, 1 by 2 and 16 by 2. Alright, 2 by 2. 2 by 2, 0 by 2, minus 2 by 5 divided by 2, and 1 by 2 and then 16 by 2. Here, 2 by 2 is 1, 0 by 2, 0. Minus 2 by 5 divided by 2 can be written as into 1 by 2. So this 2 and this 2 will get cancelled. Remaining we will have minus 1 by 5. Here minus 1 by 5. And 1 by 2, 16 by 2 is 8. Yes. Next, we shall use the formula to find out the new value. Once again, let me write the formula. New value is equal to old value minus key column value into key row value divided by key value. Right? Now, the old values are, what are all the old values that we have? The first iteration, the old values are 1 by 2, 1, 1 by 10, 0, 6. Right? We have let me write all the old values together. The first, second, third, fourth and fifth. The first old value is 1 by 2. Second old value 1. Third old value 1 by 10. Next 0 and next 6. Right? 1 by 2, 1. 1 by 10, 0, 6. Let me check it. Where are we? Yes. 1 by 2, 1, 1 by 10, 0 and 6. I have written all the 5 values, all the 5 old values, and correspondingly I am going to see the corresponding column value, corresponding row value will be a key value. Key row value will be 1 by 2. For all the 5 values, 1 by 2, 1, 1 by 10, 0, 6. For all these 5 values, the corresponding key row value will be 1 by 2. Right? Therefore, let me keep that fixed. Minus 1 by 2 by key value is What is the key value? 2. 2 is the key value. So 2 into minus 1 by 2 into divided by 2. So the corresponding column value alone will change. Okay, corresponding column value. For 1 by 2 it is 2, 1 it is 0, 1 by 10 minus 2 by 5. For 0 the corresponding row column value is 1, and for 6 it is 16. So correspondingly only this corresponding key column value will change. 2, 0, minus 2 by 5, 1 and 16. Correspondingly we can write 2, 0, minus 2 by 5, 1 by 2, 2, let me check it once again. 2, 0, minus 2 by 5, 1, 16. 2, 0, minus 2 by 5, 1 and 16. Okay, so 1 by 2, 1 by 10, 0 and 6. These are the old values, and the corresponding row value will be 1 by 2 for all the elements, and the pivot element divided by 2 will also be common for all the elements, and only the corresponding row value will change. Okay, the corresponding column value will change. For 1 by 2, the corresponding column value will be 2. For 1, the corresponding column value is 0. 1 by 10, the corresponding column value is minus 2 by 5. 0, it is 1, and 6, it is 16. Now, we can easily find out the new value. 1 by 2 minus, here we can cancel out 2 and 2. Therefore, 1 by 2, which is equal to 1 by 2 minus 1 by 2 is 0. And here we have 1 minus 1 by 2 into 0, 0 by 2. So 1 minus 0, which is equal to 1. And next 1 by 10. Here we have minus into minus plus. And this 2 and this 2 will get cancelled. We have 1 by 5 divided by 2, which is 1 by 10 plus 1 by 10, which is equal to 2 by 10. 2 by 10 can also be written as 1 by 5. And next we have 0 minus 1 by 4, which is equal to minus 1 by 4. And next 6 minus 8 by 2, which is equal to 6 minus 4, which is equal to 2. So the new values are 0, 1, 1 by 5, minus 1 by 4, 2. Okay, we shall just enter them. 0, 1, 1 by 5, minus 1 by 4 and 2. Okay, yes. Now we are supposed to find out ZJ. ZJ now we have for the first 8 into 0 plus 6 into 1. Okay, this 8 into 0 plus 6 into 1. That is 8 into 0 is 0 plus 6 into 1, which is equal to 6. Next we have 8 into 1 plus 6 into 0, which is equal to 8. Next we have 8 into 1 by 5 plus 6 into minus 1 by 5. That is 8 by 5 minus, here you have minus, so minus 6 by 5, which is equal to 5, 8 minus 6, which is equal to 2 by 5. So here we have 2 by 5. And next we have 8 into minus 1 by 4 plus 6 into 1 by 2. So minus 8 by 4 plus 6 by 2. 8 by 4 can be written as minus 2 plus 6 by 2, 3, which is equal to 1. Here we have 1. Finally, 8 into 2 plus 6 into 8. 8 into 2 is 16 plus 6 into 8, 48, which is equal to 64. Here we have 64. And then we are going to find out Cj minus Zj. Cj values are 6, 8, 0 and 0. Zj 6, 8, 2 by 5, 1. So 6 minus 6, 0. 8 minus 8, 0. 0 minus 2 by 5, minus 2 by 5. 0 minus 1, minus 1. At last, all the values of Cj are either 0 or negative. Okay, hence we have attained the solution. All the values of Cj and Cj minus Zj are 0 or negative, hence we have attained the solution. This is our solution. And at last we should write the value of x2 is 2 and x1 is 8, Z value is 64. Finally we should write that optimized value. The solution x2 is equal to 2, x1 is equal to 8 and x2 is equal to 2. Therefore, Z is equal to 64. Hence, we have attained the solution. Thank you, students.